Hello students, welcome all of you at AriserTalent. How are you all? I hope you are doing absolutely fine. So, we were discussing about our chapter, that is our first chapter of the physics, that is about electricity. In our previous lecture, we had a discussion about the heating effect of electric current, and we have discussed some of the important rules like Kirchhoff's law, which is used to determine the value of current and voltage in the circuit. Now, in the chapter electricity, we have drawn a lot of the circuits, but to identify each and every component of a circuit is very essential. So, today we are going to discuss about each and every component of the circuit that we have used there. So, in defining any circuit, the basic quantity that we have used is about the cell. So, the first and the foremost component that we have discussed is about the cell. So, here we are having components of electric circuit. In components of electric circuit, the first term we are going to discuss here will be about cell. This is a very simple thing we have discussed earlier, that what is the cell? It is a device basically used to convert chemical energy into electrical energy. It means it is a device which is used to convert chemical energy into electrical energy. Suppose we are using a cell in our TV remote, it just convert the chemical that is stored in the cell into the electrical energy. That's why it is able to operate the TV. Similar things happens with the all kind of the cells we have in the nature. Now, cells are not the simple one. Basically, there are three types of the cells depending upon their uses. It means the first cell is the primary cell that we are using in our household articles like clock, remote or toys, car, etc. These are the primary cells we have used. Secondary cells are those cells which are used for the higher purposes. And the third category of the cells we have is about the fuel cells, which are basically used in the motor vehicles and other kind of the automobile functions. So, actually cell is a device which is converting chemical energy into electrical energy. So, this is simply a cell, and if I am talking about the types of the cell, so basically cell will have a three categories, that is primary one, secondary one and the fuel cells. So, the first category is about primary cells, secondary cells, and the third thing is about fuel cells. So, these are the three category of the cells we have. Now, this is the thing about the categories of the cell. Now, we are going to discuss about some of the important terms that we have used in the numericals also, and we have a discussion about them also. But we are doing a quick revision of these terms in the description of the cell. So, our first term is about the EMF of the cell. Have you heard the term EMF? If you are not aware of it, let me tell you about what actually the EMF is. Now, the first term in this sequence is about the EMF of the cell. And EMF stands for electromotive force. What is EMF? EMF is actually electromotive force. Now, what is that electromotive force? Whenever you draw any circuit, you are using electrodes in the circuit. So, the potential difference which is created between the two electrodes of the circuit when no current is drawn from the circuit, it means the circuit is open. So if the circuit is open, we can call it as a EMF of the cell. But if the circuit is closed, we will call it as a potential difference. So there is a huge difference between these two terms. One is about the EMF of the cell and second is about the potential difference of the cell. EMF of the cell is only occur when the circuit is open. It means there is no flow of current in the circuit, and potential difference of the cell is used for identifying the term that the circuit is closed and we are drawing a current from the circuit. Now, EMF of the cell is actually potential difference or voltage developed across the electrodes of a cell when no current is drawn. And if there will be no current drawn from the circuit, it means the circuit is open. That is, circuit is open. So, it is about the EMF of the cell and it is represented by the capital E or the small e both. Now, second thing is about the potential difference that you have heard lot of time. Now, what is this potential difference? Potential difference is actually the voltage across the electrodes when the current is drawn from the circuit, and we can say that the circuit will be the closed one. So, it is the voltage across the electrodes when current is drawn, and when the current is drawn, I must say that the circuit will be closed one. That is, the circuit is closed. So, this is the very common term we had already discussed in this chapter, but this is the new term that we are discussing today, that is about the EMF of the cell, and it is again a very important term. Now, after EMF and the potential difference, we are going to discuss about our new term, that is internal resistance of the cell. So, now the third category will be, as I am writing it here, next term is about the internal resistance of the cell. Now, what is internal resistance of the cell? So, basically internal resistance will be denoted by a symbol small r, because we are using a symbol capital R for calculating the resistance of the circuit. Now, internal resistance of a circuit is basically the resistance offered to the flow of the current. It means if the current is flowing in the circuit, then what will happen? The electrolyte you are using in the circuit also have a tendency to resist the flow of the current in the circuit, and that will be known as the internal resistance of the cell. So, firstly, it is denoted by small r. It is denoted by small r, and it is basically resistance offered to the flow of current. So, it is actually the resistance offered to the flow of current, and it is the resistance offered by the electrolyte. It is the resistance offered by electrolyte. So that is called the internal resistance of the cell. Now, the internal resistance of the cell will depend upon the area of the plates of the electrodes, and it is also dependent upon the length of the electrodes you have taken. If these quantities are increased or decreased, the resistance will increase or decrease according to the condition, because it is inversely proportional to the area and the length of the electrodes. So we can say that internal resistance of a cell depends upon area of plates and length of electrodes, and it is inversely proportional to both these terms. It means if you are increasing the area, the internal resistance will going to be decreased, and if you are increasing the length of the electrodes, again the internal resistance of the cell will decrease. Now, this is the term that we are using for the internal resistance of the cell. Now, let us derive an expression that how you will find the internal resistance of the cell. So, firstly, just copy it from here. Now, let's derive an expression for calculating the internal resistance of the cell. So, the next term is about determination of internal resistance of cell. Now, for determining the internal resistance of the cell, what we are doing, we are just drawing a circuit in which a resistance is attached to a voltmeter. Here I am using the voltmeter, and you can see that one resistance is connected across the circuit, and here I am connecting the key, that is K2. This is our key, that is K2. Now, in the second half part of the circuit, what I am drawing, I am just drawing a battery here. This is our battery with the polarity positive sign and negative sign, and we are using the resistance in this circuit. This is our resistance and this is our key 1. Now, this is the circuit we have taken, and this resistance is our R. This is key 2, this is key 1, and you can see that in the first half part of the circuit, a voltmeter is also connected with the battery here. Now, what will happen in this circuit? Firstly, when I kept K2 open, if K2 is open, then no current will be flown in the circuit. If I close the key K2, what will happen? There will be the generation of small value of EMF in the circuit, because this resistance offered by the battery will be very, very small. So, what will happen in case first? Firstly, what we have taken, we have considered a resistance capital R, voltmeter V, and a key K1 and K2. Key K1 and K2. So, these are the components I have taken in this circuit. Now, in the case 1, when I kept K2 closed, so what will happen in case first? In case 1, in case 1, when K1 is open and K2 is closed, if you kept K2 closed, a small amount of potential difference will be generated, and that is called the EMF of the cell, and that will be equal to capital E. Now, in case number 2, when K1 is closed, the potential difference will be generated across this battery, and we are also provided with the resistance R. So, I must say that the potential difference V will be created and its value will be IR according to the Ohm's law we have. Now, what we want to determine? We want to determine the internal resistance of the cell. So, what you have to do? You have to take the internal resistance of the cell must be connected in series with that resistance, and its value must be small r. So, what we will do here? We will write E equal to current in circuit will having a value I, and that is equal to E R plus R. Why I have written R plus R? Because the internal resistance will be assumed to be connected in the series combination. So, this is the value of current I am obtaining here. So, from this expression we can derive the internal resistance of the cell, and it came out to be. Now, on solving this equation, I can write here I R plus R will be equal to capital E. Now, IR plus IR will give you value of E. Now, I can write IR equal to E minus IR, and from this expression you can write small r equal to E minus IR upon I. This is the expression I am getting here, and you can see that V is equal to IR. So, I can substitute IR equal to V. So, the final expression I am getting here is R equal to E minus V upon I. So, this is the basic formula for calculating the small r, that is the internal resistance of the cell. So, for this purpose, we have just taken a circuit with the two keys and kept one time K2 closed, and in the other case K1 closed. And when the key K2 is closed, a small amount of potential difference will be generated in the first half part, that is equal to the EMF of the cell, and in second case you will have a potential drop, and that drop must be equal to V equal to IR. So, what will be the value of small r? It came out to be E minus V upon I. So, just copy this derivation from here, so we can proceed to our next part. Now, our next term is about the grouping of the cells, that how you will do the grouping of the cells. So, our next term is about the grouping of cells. Now, grouping of the cells is actually done in the two ways. You can done the grouping in series, and second, you can connect all the cells in the parallel. So, we have the two conditions here. First one is cells in series, and the second one is cells in parallel. So, this is how the grouping of the cells will be done. Cells in series and the cells will be in parallel. Now, what you will do in case of the series combination, you will connect the resistances in the series having internal resistance small r1, small r2 up to rn, and the EMFs of the battery will be E1, E2, E3, and the current will flow through the circuit. Now, the first situation here is cells in series. First condition is about the cells in series. Now, how the cells in series will be connected? You have to connect the n number of cells here. A battery will be connected in series and the current I will be flowing through the circuit. This is our battery plus minus sign, and here we are taking EMF E1, internal resistance R1, EMF E2, internal resistance R2, EMF E3 and internal resistance R3 and dash dash dash. It can be covered up to EN RN because n number of resistors are connected here. Now, what will happen in this circuit? If I am going to determine the current flowing in the circuit, what I have to do? I can write the expression of the circuit. Firstly, we have seen that n number of resistors are connected in series. You have n number of resistance connected in series. So, the equivalent resistance of the circuit, that is equal to Rs, came out to be R1 plus R2 plus R3 up to Rn. Now, these EMFs which are connected with the resistances, that is E1, E2, E3, according to the polarity, what we will do? We will see that these EMFs will be added according to their polarity. So, you can also draw E1, R1 like instead of resistances here, you can also draw the cells with the EMF here. You can also draw a cells with the some EMF value. Now, if you are counting about the EMFs of the cell, then EMFs of the cell will be added according to the polarity. According to polarity, it must be added. Then, the EMF of the cell also came out to be E equal to E1 plus E2 plus E3 up to En. So, you can see that we have the n number of resistors and the n value of the EMFs here. So, according to the general formula, if I am going to calculate the current in the circuit, so I will be equal to V upon R. This is the value of the current according to the Ohm's law we have. So, I can write here I must be equal to NE upon R plus NR. So, this is the general expression for calculating the current in the circuit when the cells are grouped into the series, that is equal to NE upon R plus NR. Now, N is substituted in the coefficient side of the EMF because there are the n number of EMF we have, and this small n indicates that the resistances you have connected are n in number having an internal resistance small r. So, for the series combination, you just have this formula for calculating the current in the circuit. So, just copy this another derivation from here, so we can discuss about the cells in parallel. So, our next derivation will be about the cells in parallel. Now, our next derivation is about when the cells are connected in parallel. Second derivation is about cells in parallel. When cells are connected in parallel, what will happen? If I am connecting the m number of cells in the parallel, it means if I redraw the circuit of this system, what I will get here, firstly, we are connecting it in the parallel. So again we have connected the m number of the resistors in parallel. So what will happen in this system? Suppose I am assuming that current I will be flowing in the system. This is our resistor R and this is our E1 R1, E2 R2 and dash dash dash, you can connect it to about EM RM. So these are m number of the resistors connected in parallel. So in this combination what I have taken, m number of resistors are connected in parallel. So the m number of resistors if connected in parallel across any of the system, you can see that the internal resistance that is denoted by small r for the parallel system came out to be R upon M, because in series combination we are added the components in the sequential manner, but in the case of the parallel combination we have taken the reverse of the series combination. So I am dividing this mth term with the internal resistance of the cell. Now what is our purpose in this equation? In this equation we want to calculate the current in the parallel circuit when the cells are grouped in the parallel manner. So current will be equal to I equal to E R plus R. So in this case the current I will be equal to E R plus R by M. So this is the value of current I am getting here. If I am taking M as a LCM, here, then what I will get here? I will get here MR plus R. So we will get I equal to EM MR plus R. So again you will get the formula that in case of the series combination you have seen that we have multiplied the term N with the small resistance, that is internal resistance of the cell, but here the term is multiplied by the capital M because we have just reversed the terms here. So final expression of the current in case of the parallel combination came out to be EM R plus MR plus R. So this is the formula for parallel combination. So when numerical problems arises from this part, that how you will solve the grouping of the cells in series and parallel, you will use just this simple formula and calculate the current in the circuit. Here M will denote the number of resistance connected in parallel and N will denote the number of the resistances connected in series. So this is all about the cell we have discussed here. We have a lot of components regarding the electric circuit. We will discuss our next components in our next lecture. So this lecture is over for today. Thank you so much and have a nice day.